Good day, ma'am. I'm Rolnicky Magabang from BC1B. Example 1.10. Calculating heat transfer through conduction. A polystyrene foam is icebox has total area of 0.950 m squared and walls with an average thickness of 2.50 cm. The box contains ice, water, and canned beverages at 0 degrees Celsius. The inside of the box is kept cold by melting ice. How much ice melts in one day if the ice box is kept in the tank of a car at 35.0 degrees Celsius? Given K is equals 0.010 watts meter point degrees Celsius polystyrene foam, A is equals 0.950 m squared, T is equals to 1 day is equals 24 hours is equals 86,400 seconds. D is equals to 2.50 cm is equals to 0.025 m. Tc is equals to 0 degrees Celsius. Tn is equals to 35.0 degrees Celsius. Solution: P is equals to dq over dt is equals Ka Th minus Tc over D is equals to 0.010 watts minutes point degrees Celsius times 0.950 m squared times 35.0 degrees Celsius minus a 0.0 degrees Celsius. P is equals to 13. So ang answer ito give ko pa nga ang gi-divide ang 0.025 0.0250 m gi-divide sa taas then ang nagawas again P is equals to 13.3 watts. So Q is equals PT is equals to 13.3 watts times ang kuan ng gikuan sa 24 hours it is 86,400 seconds. So ang equals ng gipagkuan kay 1.15 times 10 square root of 4 joules. M is equals Q L over F LF is equals to 1.15 times 10 square root of 4 joules divided by 334 times 10 cube joules kg. Ang answer yan kaya ang gawasan sila pag divide is 3.44 kg. So this is the example 1.12, calculating the flow of mass during convection. The average person produced heat at the rate of about 120 watts when at rest. At what rate must water evaporate from the body to get rid of all this energy? For simplicity, we assume this evaporation occurs when a person is sitting in the shade and surrounding temperature are the same as skin temperature, eliminating heat transfer by other methods. Given heat rate of person is equals to 120 watts when at rest. Solution: Q is equals to M and MLV. Q over T is equals to MLV over T is equals to 120 watts. Gi-convert din ng 120 watts sa 120 joules second. MT is equals to M over T is equals to 120 joules second over LV. So LV is equals to 2,430 kg is equals to 2,430 joules. G na yun. M over T is equals to 120 joules second over 2,430 G second. So pag divide ay ang gawas na kay 0.0494 GS is equals to 2.96 G min. This is the example 1.13, calculating the net heat transfer of a person. What is the rate of a heat transfer by radiation of an unclothed person standing in a dark room whose ambient temperature is 22.0 degrees Celsius? The person has a normal skin temperature of 30.0 degrees Celsius and a surface area of 1.50 m squared. The emissivity of skin is 0.97 in the infrared part of the spectrum. where the radiation takes place given ambient temperature is equals to 22.0 degrees Celsius. Skin temperature is equals to 33.0 degrees Celsius. A is equals to 1.50 m squared. Emissivity of skin is equals to 0.97. PFAM, Van Boltzmann law of radiation ang gamiton. P is equals to O AET square root of 4. Solution T or T2 is equals to 295 K. T1 is equals to 306 K. Q over T is equals to O E A T2 square root of 4 minus T1 square root of 4. So, ang kuha na yun kay is equals to 5.67 times 10 square root of negative 8 joule second point M2 point K4 times 0.97 times 1.50 M2 times 297K open parenthesis square root of 4 minus 306K cross parenthesis 4 cross parenthesis square root of 4. So ang Gauss din is negative 99 joule second. Convert din is equals to negative 99 watts.